Hey hackers and tech enthusiasts, welcome to Protocol, the series where we unravel the history and mysteries behind the technology shaping our digital world. I'm your host Dade, and today we're talking about one of my favorite protocols, Secure Shell, or SSH. SSH is a Swiss Army knife of a protocol, but its roots are simple: to replace existing insecure remote access tools like Telnet. Designed in 1995, SSH was made up of just two commands, both of which were designed to be secure replacements for existing commands called the Berkeley R commands. The first command, Secure Shell, or SSH, was designed to be a secure replacement for the existing remote shell, or RSH command. The second command was slogin, a secure replacement for the rlogin command. The most common SSH implementation today is OpenSSH, which was released in 1999 by the OpenBSD developers. These days there are implementations for all kinds of operating systems and architectures, from your MacBook to your Linux desktop to your home router to the little embedded devices powering your smart toaster. We can use it to get shell access, run a remote command, forward traffic, and even transfer files. So, how does Secure Shell work, and what high-level things should you know about it? Find out this time on Protocol. At a high level, SSH is a client-server protocol that establishes encrypted tunnels between a client and a server, enabling the transmission of information in a way that only the two parties involved can understand. It achieves this through the use of public key cryptography to authenticate the devices that are trying to talk to each other. Each device has its own host key pair, a public and private key that are used to establish secure communication. Before continuing, I suppose it's worth calling out that it's a little bit of a misnomer to call SSH a protocol, and maybe this is a prime example of where one protocol should be split into many videos. It's actually a multiple layers of protocols. The first layer is the transport, which handles the server authentication and establishing the confidentiality and integrity of the communications using the aforementioned public key cryptography. The next layer is for user authentication, ensuring that the remote user is authorized to log in as a local user on the system. This layer can use a variety of mechanisms to authenticate users to a remote system, most commonly either a password or a public key cryptography. It is important to make a distinction, though, that user authentication uses a different set of keys than host authentication, even though the keys may look similar. The third layer is the connection, which is basically just a way to handle multiple communication channels over the same encrypted transport tunnel. Over the years, SSH has become quite robust and allows establishing multiple connections to a remote server through the same transport layer, not only allowing for multiple shell connections, but also for arbitrary tunneling of TCP ports, X11 connections, and Unix domain sockets. In my opinion, it's this flexibility that makes SSH so useful today. These three protocols are actually split up into their own RFCs with the Internet Engineering Task Force. The transport layer is defined in RFC 4253 and is also the layer that's responsible for SSH reserving the port 22. The user authentication protocol is defined in RFC 4252 and outlines different methods for authenticating a user to the server. Finally, the connection layer is defined in RFC 4254, which outlines the three standard communication channel types: shell, direct TCP/IP, and forwarded TCP/IP. We'll get into the meaning of these in just a minute. There are also a variety of other SSH RFCs, which cover things like the architecture of the protocol, using DNS to publish key fingerprints, using Diffie-Hellman to exchange keys, the formatting of SSH public keys, and quite a few other things. You don't need to know about all of these things, but there's plenty to read if you're interested. Let's take a quick dive into how we use SSH by going through a demo of using it to open a remote shell on a server. This is one of the three standard communication channel types mentioned before, shell. I've already spun up a server in advance, and we can simply run the SSH command with our username and the IP address. We'll be prompted to accept the host key, and then we'll be prompted for our password. It's important to note that this is the password of our user on the remote machine, not our password on our local machine. And just like that, we've got a shell on the remote server. Way easier than rolling up to the data center, walking to our server, and pulling out the monitoring keyboard. But let's go one step further. I mentioned that we can use public key cryptography to authenticate our users, so let's set that up. In another window, we're going to run the SSH keygen command to generate a key pair. We'll be prompted to set a password on the key. We're going to skip that for this demo, but I do recommend that you set a password for any keys that you actually use. In my past life as a red teamer, I used to love finding unsecured SSH keys and taking them with me, so I'm a little paranoid about my SSH keys these days. Once we've generated the keys, we can copy the public key to the server. There are two ways to do this: the SSH copy ID command and the manual way. SSH copy ID is a little bit easier to make sure you get it right, so we'll use that and then look at what it did on the server. We can simply run SSH copy ID -I and then the path to our key file, and then the address that we want to copy it to. It will prompt us for our password again, and then we'll have copied our key. On the server, we can see that a new directory was created in our home directory, the SSH directory, and inside it is authorized keys, which contains a copy of our public key. Now we can rerun the SSH command from earlier, and just like that, we've got another shell on the remote server. If shell was one of the 3 standard communication layer types, next I suppose we should talk about the direct TCP/IP and forwarded TCP/IP layer types. Both of these layer types represent the ability to forward arbitrary TCP ports over SSH, the only distinction being the direction of the forward. It is easier to think of these as local port forwarding and remote port forwarding, though even then it can be a little bit confusing. A local port forward is used to establish a local port on your computer that can talk to a remote port on the server. Say you wanted to only allow secure access to a service that doesn't support any encryption. This service can do its thing, but only be listening for connections that originate on the server. And an SSH local port forward can create a tunnel where the SSH server says, you can talk to my local port by talking to your local port, and I'll make sure it gets where it needs to go. Conversely, a remote port forward, also called reverse port forwarding, is used to set up a port forward from the remote server to your local client. You can use this to allow a remote server to talk to a service running on your device, for as long as the SSH tunnel stays open. In that case, the SSH server says, hey, if I get any traffic on port 12345, I'll forward it to your port 12345 over this tunnel. Finally, there's one more type of port forward that SSH can do, which is a dynamic port forward, or using SSH as a SOCKS 5 proxy. We're not going to dive deep into exactly what that means right now, but basically a dynamic port forward lets you say, hey, I'm going to send arbitrary traffic to this port on my machine, and I want to tunnel it through you. You can use this feature to set up proxy configurations in your browser to appear as though your requests are originating from your server, as just one example. I hope this has given you a small taste of the power of SSH. SSH is a super capable protocol that can be used for securely proxying your traffic, securely copying files between devices, and securely giving you a remote shell on a machine so that you don't have to be sitting right in front of it. The possibilities with these primitive capabilities are nearly endless. While I have many fond memories of abusing SSH to access things I wasn't supposed to access while red teaming, I also use SSH on a near daily basis through my self-hosted developer tunnel solution, which I wrote about in my blog post titled Can You Grok It?, which I'll link down below. Are you interested in learning more about SSH? Do you want a deep dive on how the secure transport layer is set up? Or maybe an exploration of the many uses of the port forwarding capabilities? Or maybe you'd like to learn more about the RSH protocol mentioned at the beginning of the video? Let me know in the comments down below. In our next episode, we're going to take a look at the Simple Mail Transfer Protocol, or SMTP, which will be the first of several episodes on email-related protocols. If you're interested in seeing more of this series on protocols, give this video a thumbs up and make sure you're subscribed so that you can get notified when the next episode goes live. With that, I've been Dade, this has been Protocol, stay curious, stay connected.